Data, lesson 6.1, file size. So before we've talked a little bit about binary numbers. The reason computers use binary numbers is because they are, in essence, they're made of transistors. Transistors control electrical current, so 0 is off and 1 is on. So everything it interprets has to be in those ones and zeros. So when we did like binary addition and stuff, we talked about like each 1 and 0 is considered a bit. And in most computer systems, data is actually stored in what they call bytes. So a byte, spelled B-Y-T-E, 1 byte consists of 8 bits. Okay. Since a byte is 8 bits, so you might have like a sequence of 8 ones and zeros, or you might see a 2-digit hexadecimal number. Okay. For example, like let's say we had this hexadecimal value. How many bits and bytes are we actually storing here? Right? Pause the video and see if you can figure that out, and then come back and see the answer. All right, so remember that for hexadecimal is base 16, and 2 to the 4th is equal to 16. So if you recall back from like the binary addition and the conversion, every 4 bits corresponds to a hexadecimal value. All right, so basically we have 1, 2, 3, 4, 5, 6 hexadecimal values, 4 bits each. So if we do 6 times 4, that's actually a total of 24 bits that your computer is using to store that hexadecimal value. Now again, most computer systems talk about bytes instead of bits. So if you take the number of bits you have, 24, and divide that by 8 bits per byte, that would actually be a storage of 3 bytes. So when you're looking at file sizes and stuff, typically you're not going to see just bits or bytes because you're storing more than that. So again, a single bit is just a 1 or a 0. It's an on or off signal. If you wanted to store a single character or number, so like if you wanted to store the number 7, or if you wanted to store the letter F, okay, that's going to be 8 bits. That's going to be a byte. So basically almost pretty much every button you hit on your keyboard, every time you hit a button, that's a byte. All right, now when we start creating files, obviously that's going to grow a lot, okay? So text file. So let's say you open Microsoft Word or Google Docs or some kind of word processor and you type up an essay. That's a text file. And if you look at the storage for that, that's going to typically be in the kilobytes, okay? So kilo normally kilo means 1,000, but remember in computer science, it's base 2. So the closest thing to 1,000 in base 2 is 1,024, right? If you Google this, there's kind of, some people are like, okay, well, we'll just use 1,000 because it's a good approximation. But truly, your computer is using 1,024. So a more accurate description, an accurate calculation, will use the 1024. But for estimation purposes, 1,000 can sometimes be used. Okay, especially if you don't have a calculator, 1,000 is really easy to like divide by or multiply by. Now, when you start doing like audio files for like for instance, a single song, like if you go download a single song, it's probably going to be a megabyte. Also, image files are typically megabytes, right? And that's going to be 1,024 kilobytes. Okay, so every time you increment here, so kilo to mega, you're always going to be doing 1,024 to the next level. Now, let's say instead of just a single music file, you download a whole entire movie or something. That is going to be a lot larger, and that's typically going to be gigabytes. Terabyte is kind of more standard now, I think, in most PCs. Terabyte is going to be a lot larger. Like you could store, and this is a rough estimate, guys, but let's say you had 250 movies you wanted to store. The size of that storage would be in the terabyte size. If you're interested, so this is my personal computer here. I have like a PDF file. If I right click it and I go to properties, it will tell you the size on the disk. Okay, so see this file. PDF is kind of like usually like a Word document, like a text file. So kilobytes, what we expected. It also tells you how many bytes here, so you can actually practice your conversion there if you wanted. Size on disk, that's how much actual storage space it is required. Let's see, I have an MPEG video. This is a really short video. I don't know if it's going to be... Oh wow, it's telling me 0 bytes, so that is definitely wrong. Oh, that's because this... Okay, never mind. I know why it's wrong. That drive is no longer on my computer. Here's an image file. Oh, that one's on my computer anyway. Okay, I know I have some. Okay, here's some that are actually on my computer. So let's go to properties. This is an image file. So notice here the image file is 1.74 megabytes, okay, which is 1,834,559 bytes. So again, that's 1024 times 1024 essentially. So we would have to work on that conversion there. So anyway, if you're curious, you can always go to your computer and you could go to those properties for some of your file size and practice with the conversion if you'd like. All right, so let's do some practice with the unit conversion. So let's say if a single character is stored in 1 byte. Okay, that's pretty standard. How many kilobytes would be required to store 2,098 characters? Okay, so first of all, you want to think about you're given a byte and you're trying to go to kilobytes. So you want to make sure you know that conversion. 1 kilobyte is equal to 1,024 bytes. All right. Now, we're not given a kilobyte, we're given a byte. So one technique you can use here is the information that you're given. Try to get the unit rate on that. So if we divide both sides of this by 1024, we also get that 1 byte takes 1 over 1,024 kilobytes. That might be a little more useful for us because we know that we have 1 byte per character. So now that we know this conversion, we have 2,098 characters, each at 1 byte. So we have 2,098 bytes that we're trying to convert. So let's take this byte conversion to kilobytes, the 1 over 1024, and multiply that by the byte size that we have, which again is 2,098. So if we do that, we get 2,098 divided by 1024, which is 2.049. Now on the Praxis, I don't think you're allowed a calculator, so obviously that is going to be a little bit hard to do without a calculator. So on the Praxis, you're going to have multiple choice questions. And the best thing to do for that would be to just use the idea of 1,000. So your answer should be about 2.098. Okay, so you would look at your options and you would find the one, because it's pretty close to it. It's not going to be exactly correct because we're using 1024 base, but you should be able to estimate that using 1,000 pretty easily. Oh, just realized this is not actually in slideshow mode, guys. Sorry. There. It's a little bit bigger now, right? Okay, so let's try this unit conversion. If one text file is 6.12 kilobytes, how many of those files could you fit in a 2.08 megabyte? Right? And you pause the video, work on your conversion, and then you can come back. Okay, so again here, you want to realize that you're going from kilobytes to megabytes, so you want to make sure you're using this conversion. 1 megabyte is 1024 kilobytes. You could divide both sides by 1024, just like we did previously. And again, I do this because I like to have my unit rate on the input. Okay, our input is in kilobytes, so I like to have my unit rate on the input. That's just kind of a personal preference. This isn't the only way you can do a conversion here. There are other ways to do it, but whatever you're comfortable with, that's how you wanna work it. So I like to have my unit on the input. And then we would just multiply both sides of this by 6.12 because that's how many kilobytes we have. So 6.12 kilobytes would be 6.12 divided by 1024 megabytes. All right. So again, this one is a little hard to do without a calculator, but you could once again kind of use that 1000 base to kind of help here. So like on this side, 6.12 divided by 1000 is 612. Not 612. I'm multiplying it. I know you need to divide by that. So we'd have three. We have to move our decimal 3 places to the left. So 0.0612. Now, just to kind of compare that, guys, just so you know, if you do it by 1024, I'm going to do this in my calculator real quick. You get 0.005976. Okay, so it's not a pretty number. Again, accurately, 1024 is the right number to use, but notice, again, the approximation's pretty close. So when you're doing this by hand, the thousand's a lot easier. Okay, so we have that's how many megabytes we have for the 6.12. So like each text file is going to take this much megabytes. So now we want to take, okay, well, how we have a total of 2.08 megabytes. We want to divide that by our approximation here. All right, so this one, I don't know if there's really any easy way of doing this. You can move your decimal 2 places to the right on both of these. So this is like 208 divided by 0.612. I see a 2 in the top and a 6 in the bottom. So I see like a 1/3. So that might help kind of be like, okay, well, if you don't know, 1/3 is like 3, 3, 3, 3, 3, 3, forever. So you'd want about 333. To get the actual value, you would have to multiply. Honestly, the 348 is the correct, like exact actual answer. If you do 2.08 divided by 0.00612, you would get, for this, you would get about 340. So again, there's a margin of error here. Your answer choices on the Praxis should be within reason. Like even estimating it, you should be able to gauge like which one it would be. But honestly, you really should have a calculator for the exact, like actual one. To get the 348, which is the real answer in your computer system, you'd really want to use a calculator for that, because there's really no way you would ever think of this number in that division. But hopefully some of these some of these tips are just to help you, okay, if we have our choices, which one could we estimate based on some of these estimation techniques?